हे शॉर्ट आन्सर सेकंडची आन्सर की 3 मार्किशला क्वेश्चन्स असतात. फर्स्ट क्वेश्चन आहे एक्सप्लेन द नीट सर्किट डायग्राम हाऊ यू विल. हॅलो फ्रेंड्स, कसे आहात? आज आपण महाराष्ट्र शालेय शिक्षण व क्रीडा विभागाने 2023 क्वेश्चन बँक फिजिक्स या विषयाची पाठवली होती. त्याची आज आपण आन्सर की बघणार आहोत. चला तर मग ती आन्सर की आपण बघूयात. आज आपलं नवीन चॅप्टर करंट इलेक्ट्रिसिटी हा चॅप्टर बघत आहोत. चला तर मग त्या क्वेश्चनकडे. हे शॉर्ट आन्सर सेकंड 3 मार्क इचला असतात. एकूण हे 7th क्वेश्चन आहेत. याची आन्सर की आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे शॉर्ट आन्सर सेकंडची आन्सर की 3 मार्किशला क्वेश्चन्स असतात. फर्स्ट क्वेश्चन आहे एक्सप्लेन द नीट सर्किट डायग्राम हाऊ यू विल डिटरमाइन द अननोन रेजिस्टन्स युजिंग द मीटर ब्रिज. Answer construction. First, meter bridge consists of 1 meter, a long wire of uniform cross section stretched on the meter scale, which is fixed on the wooden table. Second, the end of the wire are fixed below to L-shaped metallic strip. A single metallic strip separated to L-shaped strip, leaving two gaps, left gap and right gap. Third, usually an unknown resistance X is connected in the left gap and a resistance box is connected in the other gap. Fourth, on one terminal of the galvanometer is connected to a point C on the central strip, while the other terminal of the galvanometer carries the jockey J. Temporary contact with the wire AB can be established with the help of the jockey with a cell of EMF E along with a key, and rheostat is connected between the point A and B. ही डायग्राम आहे. Working. First, a suitable resistance R is selected from resistance box. Second, the jockey is brought in connected with AB at various points on the wire. AB and the balance point null point D is obtained. The galvanometer show on the deflection with the jockey is at the balance point point D. Third, it is lets the respective length of the wire between A and D and that between D and CB, LX and LR. Fourth, you then using the balancing condition X divided by R is equal to RAD divided by RDB equation first, where RAD and RDB are resistance of the part AD and DB of the wire respectively. Fifth, if L is the length of the wire, rho is a specific resistance, and A is the area of the cross section, then RAD is equal to rho LX divided by A equation. Second, RDB is equal to rho LR divided by A equation. Third, from equation 1, 2 and 3, X divided by R is equal to RAD divided by RDC is equal to PLX divided by A divided by PLR divided by A. Therefore, X divided by R is equal to LX divided by LR. Therefore, X is equal to LX divided by LR into R. Thus, knowing R, LX and LR, the value of unknown resistance can be determined. Question number second. State any two sources of error in the meter bridge experiment. Explain how they can be minimized. Answer. Source of error. First, the cross section of the wire may not be uniform. Second, the ends of the wire are soldered to the metallic strip where contact resistance is developed, which is not taken into account. Third, the measurement of Lx and Lr may not be accurate. To minimize the error, first the value of the R is so adjusted that the null point is obtained around the middle one strip, one third of the wire between the 34 into bracket between 34 centimeter and 66 centimeter, so that percentage error of the measurement of Lx and Lr are minimum and nearly the same. Second, the experiment is represented by interchanging the position of unknown resistance X and known resistance box R. Third, the jockey should be tapped on the wire is not slided. The jockey is used to detect the whether there is accurate through the center branch. There is possible only a tapping the jockey. Question number third. What is the potential gradients? How it is measured? Explain. Answer. First, the potential gradient K is defined as a potential difference per unit length of wire. Second, it is measured as V divided by L is equal to ER divided by L into bracket R plus R, where V is the potential difference between the 2 points, L is the length distance between the 2 points. Question number third point, explanations. A potentiometer can consist of long wire AB and length L and resistance R having a uniform cross section area A, where cell of EMF E having the internal resistance R is connected across AB as shown in the figure. Figure A. See, when the circuit is switched on, the current pass through the wire. Current through AB I is equal to E divided by R plus R. Equation first. D. Potential difference across AB. VAB is equal to IR. VAB is equal to ER divided by R plus R from equation first. Therefore, the potential difference per unit length of the wire is VAB divided by L is equal to ER divided by L into bracket R plus R. As long E remains constant, VAB divided by L will be remains constant. F. VAB divided by L is known as potential gradient along AB and it is denoted by K. Potential gradient can be defined as the potential difference per unit length of the wire. Question number 4. Describe how a potentiometer is used to compare the EMFs of two cells by connecting the cells individually. Answer. First, a potentiometer circuit is set up by the connecting a battery of EMF E with a key K and a rheostat such that a is higher potential than point B. Second, the cell whose EMF are to be compared as connected with their positive terminal at a point A and negative terminal to extreme terminal of two-way key K1 and K2. Third, the central terminal of the two ways key is connected to a galvanometer. The other end of the galvanometer is connected to a jockey J. Diagram आहे. Fourth, key K is closed and then the key K1 is closed and K1 K2 is kept open. Therefore, the cell of EMF E1 comes into circuit. 5. The null point is obtained by touching the jockey at a various point on the potentiometer wire AB. 6. Let L1 be the length of the wire between the null point of the point A. Here L1 is corresponds to EMF E1 of the cell. Therefore, E1 is equal to K L1 equation first, where K is the potential gradients along the potentiometer wire. 7th, now key K1 is kept open and key K2 is closed. The cell of EMF E2 now comes in the circuit. Again, the null point is obtained with the help of the jockey. 8. Let's L2 be the length of the wire between the null point and the point A. Here L2 corresponding to the EMF E2 of the cell. Therefore, E2 is equal to K into L2 equation second. 9th, dividing equation first and equation second, E1 divided by E2 is equal to L1 divided by L2. Thus, the EMF of the two cells can be compared, and if any one of EMFs is known, the other can be determined. Question number 5, numerical. A cell of EMF 1.5 volt and negligible internal resistance is connected in series with the potentiometer of length 10 meter and total resistance 20 ohm. What resistance should be introduced in the resistance box such that the potential drop across the potentiometer is 1 microvolt per centimeter of the wire? Solution given. R is equal to 20 ohm, L is equal to 10 ohm meter, E is equal to 1.5 volt, K is equal to 1 mV per centimeter is equal to 1 into 10 raised to minus 6 per 10 raised to minus 2 volt per meter. There is equal to 10 raised to 4 volt per meter. To find external resistance RE, formula K is equal to V divided by L. Calculation. Since I is equal to E divided by R plus RE, also V is equal to IR is equal to ER divided by R plus RE. From formula K is equal to ER divided by into bracket R plus RE into L. R plus RE is equal to ER divided by KL. Therefore, RE is equal to 1.5 into 20 divided by 10 raised to 4 minus 4 into 10 is minus 20 is equal to 30,000 minus 20 is equal to RE is equal to 29,980 ohm. Answer word problem असल्यामुळे answer word मध्ये the external resistance should be 29,918 ohm. Question number 6. In a meter bridge, the balance point is found to be the 39.5 centimeter from the end A when the resistor R is of 12.5 ohm right gap. First, determine the resistance of X left gap. Second, determine the balance point of the bridge if X and R are interchanged. Third, what happens if galvanometer and cell are interchanged at the balance point of the bridge? Answer given. Lx is equal to 29.5 centimeter, R is equal to 12.5 ohm, Lr is equal to into bracket 100 minus Lx is equal to 100 minus 39.5 is equal to 16.5 centimeter. First, since the bridge is balanced, x divided by r is equal to Lx divided by r. Therefore, x is equal to Lx divided by Lr into r is equal to 39.5 divided by 16.5 into 12.5 is equal to 8.16 ohm. Second, when x and r interchange, then their respective length also get interchanged. Therefore, new balance point will be at 16.5 centimeter. Third, if the galvanometer and the cell are interchanged, then the balance point remains unchanged. Question number 7. The EMF of the standard cell is 1.5 volt and balanced by a length of the 13 centimeter of potentiometer. With a 10 meter long wire, find the percentage error in a voltmeter which is balanced at a 315 centimeter when it is reading is 1.8 volt. Solution given. E1 is equal to 1.5 ohm, L1 is equal to 300 centimeter, L2 is equal to 315 centimeter. From individual cell method of potentiometer, E1 divided by E2 is equal to L1 divided by L2. Therefore, E2 is equal to E1 into L2 divided by L1 is equal to 1.5 into 10 into 350 divided by 300 is equal to 1.75 volt. But giving reading is 1.8 volt error, therefore error 1.8 minus 1.75 is equal to 0.05 volt. Therefore percentage error is equal to 0.05 divided by 1.75 into 100 is equal to 2.8571%. आन्सर वर्डमध्ये असल्यामुळे क्वेश्चन वर्डमध्ये असल्यामुळे आन्सर वर्डमध्ये द पर्सेंटेज एरर इन व्होल्टमीटर इज 2.8571%. इथे आपले शॉर्ट आन्सर सेकंड कंप्लीट झालेले आहेत.